11F, the area underneath the curve. Today we're learning to find the area under the curve, and what you need to be able to do is to use integration techniques to find this area under the curve, but also specifically you need to recognize when the area is going to be negative and then use integration properties to include this area in the solution. Now that'll make a lot more sense after we complete this little example. I want you to try and find the area between 0 and 2 using the techniques that we learned last lesson. So if you remember, we learned how to integrate, which is a way of being able to find the area. So pause the video and give it a go yourself. Now, in order to find the area, what you might have done is integrated between 0 and 2, because that's the start and the end of this particular function. So let's go ahead and integrate that together. I'm going to end up with a fraction there, but the rest cancel out quite nicely when I integrate. And that's between 0 and 2. So when I go ahead to substitute in, I get 2 to the power of 4, which is 16, 2 to the power of 3, which is 8, and 2 squared, which is 4, minus, and then when I sub in 0, I just get 0. 16 divided by 4 is just 4. So 4 minus 8 is negative 4, plus 4 is 0. So I end up with an area of 0 units, which kind of doesn't make sense because I can clearly see that there's area here, but it's giving me 0 units overall. Now, the reason that that's happened, as you might guess, is because the area that is above the axis is actually the exact same area that is below. When we integrate, we actually end up with a thing called signed area. So if the area is above, it comes out as positive, and if the area is below, it comes out negative. So we can't just integrate straight from the start to the end to be able to find that area. What we need to do is take into account where is the area going to be positive, where is it going to be negative, integrate them separately, and then add them together in order to account for that signed area. That in a nutshell is the technique of being able to find the area underneath the curve. So to calculate the area enclosed by a curve, what you need to do is to integrate each of the regions that fall above or below individually. The regions below the x-axis have a negative signed area, and the regions above have a positive signed area. The total area is where we're going to add each of these regions, but you need to make sure that if the region is below the x-axis, such as that one there, that it becomes a positive. Now, how do we do that? If the area itself is negative, there's three different ways of being able to do it. Two that I would suggest that you could actually use. So the first way is if I integrate between, say that's A and B, and I know that area is going to come out as a negative, what I could do is put a negative in the front, so that the negative multiplied by the negative area is going to give me a positive. The other thing I can do, if you remember from the previous exercise, if you integrate with the upper bound at the bottom and the lower bound at the top, we're going to end up also with a negative area or a negative value. Now, because the area is going to come out as negative, and because I've integrated from smaller to larger, it's going to also end up negative, I end up with a positive value. The last way that you can do, you can integrate if you've forgotten, you might not be sure about this. That's why I'm suggesting you don't need to necessarily remember this. Feel free to forget it if you'd like, but you can take the absolute value, which again, if you're not too sure what that means, essentially if you've got a negative value, it just turns it into a positive. But it'll make a lot more sense, I think, if you just use techniques 1 or 2. Okay, so in saying that, to be able to find the total area of this, we've got A1, and then you can see minus A2, because A2 in itself is negative, and then I've got the negative in front to make it a positive, and so on. So overall method, first thing you need to do is sketch. Otherwise, how will you know if something's above or below? Sketch it, label the x-intercepts, because that's going to be your bounds. What you need to do is write separate integrals for each of the areas that fall below or above, and then find the integral of each individual section using the x-intercepts of A and B. Take the absolute value, or I would suggest chucking a negative in the front or flipping the boundaries, and then finally add all the areas together. Okay, so let's start off with example 16. It says to evaluate this between -1 and 4. So we can see that this is a function here, x times 3 minus x, and we want to evaluate between -1 and 4. We know this is going to give us a value, but that value is not going to be the area because we haven't separated it, and we're not taking account into the fact that that's a negative area and that this is positive. But as it is just asking us to evaluate, it is not asking us to find the area, so we don't need to create any kind of separation at this stage. So in order to evaluate it, first thing I'm going to do is expand, because I can't integrate a function multiplied by another function. I'm then going to go ahead and integrate this, ending up with some lovely fractions, as you'll notice will be the theme of this chapter. and I'm going to go ahead and substitute in. So 4 squared is 16, and 4 cubed is 64. Now I'm going to go minus, and then now I'm subbing in the -1. So -1 squared is just going to be +1, and -1 cubed is going to be -1. I can now go ahead and put in all of my values together. So 16 divided by 2 is going to be 8, and then 8 times 3 is 24. 64 divided by 3, I can't really do much about that. And then I've got 3 on 2 plus 1/3. So 3 times 3 is 9, 2 times 1 is 2, so 9 plus 1 is going to be 10 on 6, because we multiply out the denominators. Now, if you go ahead and work this out on your calculator, I'm just going to take a bit of a shortcut just for time's sake. You should get a value that is 5 on 6. All right, now that is the answer to that integral, but it is not the area, because as we said, to find the area, we have to find each section individually. So we're going to now go ahead and find the exact area of the shaded region. I can see that I've got 3 regions here, A1, A2, and A3. I can also notice that A1 is negative, so to make it positive, I'm going to put a negative in front of that and a negative in front of that, so that the negatives multiply. A2 is already positive. And you can see here, I've now got a little bit of a plan. Negative A1 plus A2 minus A3 should give me the answer. The other thing you might notice, because this is a quadratic, this region and this region are actually exactly the same. So what I could do is I could just do 2 times area 1 to be able to save me a little bit of time from having to do it twice. So I'm going to create a little plan for myself. I've got 2 lots of A1 plus A2, and notice I've put the negative in front to remind myself to make it a negative. I'm now going to go ahead and substitute in the correct integrals. So I'm going to end up with -2, and I'm going to integrate from -1 to 0 of my function, which is 3x minus x squared dx, plus, and then area 2 is from 0 to 3 of 3x minus x squared dx. All right, let's prepare for some wonderful fractions to pop up. So when I integrate this, I'm going to end up with 3x squared on 2 minus x cubed on 3. That'll be from -1 to 0. 3x squared on 2 minus x cubed on 3. That's from 0 to 3. Now we're going to go ahead and substitute in. First of all, when I put in zeros into here, I'm just going to end up with 0. So that's quite lovely. Open the bracket. When I put in -1, I'm just going to end up with +1 times 3 on 2 is 3 on 2. -1 into here is -1, but negative times a negative is positive, so I'll end up with plus 1/3. Okay, that's that one done. Into here. 3 squared is 9 times 3 is 27 on 2. And then here, 3 cubed is 27 on 3. Minus, now if I put in 0 into both of them, I'm just going to end up with a 0. Okay, again, I don't really have many lovely fractions here. We can kind of work them out. 3 times 3 is 9, 2 times 1 is 2, that's going to be 11. That's a negative, so that'll be -11, and then times -22, sorry, -11 on 6, and then -2 is going to be +22 on 6, plus, and then here, I've got these fractions over here. When I work them out, I end up with 27 on 6. And when I add these two together, I get 49 on 6 units squared. I just realized I'd made a silly mistake. You might have already picked it up. As I always do, 3 times 3 is 9, plus 2 is 11, not 10. But that answer is still correct. All right, there we go. That's example 16. Let's go ahead to look at example 17. So example 17, this time they haven't given us the graph. We have to do that ourselves. We're going to sketch the graph of f of x is equal to x squared minus 4. Find the area of the region enclosed between 1 and 4. So first things first, I'm going to go ahead and sketch this graph. It's going to look something like this. That's at 4, and I want it between x is 1 and x is 4. So here might be 1, and here might be 4. These are my boundaries. Oops, that's quite big for my area. Let's try that again. So this is the area that I want to find. Labeling them, that's A1 and A2. We know that A1 is negative and A2 is going to be positive. So from there, I can write my little plan. I'm going to go negative A1 plus A2. I'm going to go ahead and start integrating, or rather set up my integrals. So from 1 to, well, actually I need this value first. That is going to be the x-intercept, which for this parabola is 2. X squared minus 4 dx plus 2, 4, x squared minus 4 dx. Now I can go ahead and integrate and start substituting in as normal. That'll be x cubed on 3 minus 4x plus x cubed on 3 minus 4x. At this point, this should hopefully be quite routine. I will go through the steps with you, but you can hopefully be able to work with these fractions by yourself. If you feel like you're not really strong with fractions, please go ahead and work on that, because this could very easily be an exam 1 question, and it's also very easy to make a mistake. In fact, I've just recognized one. I forgot to put my negative in front. Okay, let's go ahead and do a few substitutions. So starting up here, 2 cubed is 8, minus 4 times 2 is 8, and then minus 1 on 3. Now notice I'm not writing the bracket. I'm going to make everything negative right away. So this is something you can do, but you need to be careful. So usually I would have the bracket here, then I would expand. I'm just going to make it negative straight away. So 1 times 4 is, negative 4 is negative 4, but then minus that is going to be plus 4. Of course, there is a negative that is out the front of all of that as well. All right, next bracket, 4 cubed, 64 on 3. 4 times 4 is 16, minus, again, I'm not putting the bracket, I'm just going to make them all negative straight away. 2 cubed is 8. And then plus, because negative times negative, 4 times 2 is 8. All right, adding these all together, I'm going to end up with here negative 16 on 3 plus 11 on 3 plus, and then for the second part, I'm going to end up with 16 on 3 plus 16 on 3. That'll be 5 on 3 plus 32 on 3, and when you add that together, 37 on 3 units squared. No, I did not do that in my head. Fractions don't work that well for me. It's just something I've pre-prepared because I'm sure that you can work with your fractions, but it does take a little bit of time. All right, we're up to the last one, example 18. Now, this time what we're going to do, because it's the same thing again, we're actually going to do this one on the CAS calculator. So first thing we're going to do is sketch. We can sketch it on the CAS. I'm just going to do it by hand because it is pretty easy to sketch. And then we're going to write up our integrals and put them into our CAS calculator. Now, what we can notice here is that this is a negative cubic with x-intercepts at 0, 2, and 3. So that's the first thing I'm going to put in and sketch it away. This is my area. I can actually go larger this time. This is my area below and my area above. So if I call this area 1, we want the negative version of that. And if this is area 2, I want the positive version of that. So my plan, negative A1 plus A2. I'm going to integrate between, I haven't done a very good job of writing my intercepts, but I'm going to integrate between 0 and 2, negative version of f of x dx, plus, and then 2 to 3 of f of x dx. Putting this on the calculator, I can define it straight away. No need to expand. The calculator will do all the work, and then we can put in those boundaries. So jumping onto our CAS calculator, first thing I'm going to do is go ahead and define. I'm just going to define it as f1, oops, already got a function like that, f2 of x is equal to x times x, actually it was, I think, 2 minus x times x minus 3. Done. Then I'm going to go ahead and calculus integral. Now the first one was negative, and that was between 0 and 2. of f2 of x. And then for the next one, it was plus integral between 2 and 3 of f2 of x. Now, I don't know how it is that I memorized that. Let me just check that that's actually all correct. 0 to 2, 2 to 3, negative out the front, x2 minus x minus 3. Fantastic. All right, good to check your stuff. When you press enter, you get 37 on 12. So that is how you would complete it on the CAS calculator. That's it for this exercise, so please go ahead and practice some questions.